Well, I've got a few people still walking in, so we'll start in a minute or so. Yeah, doors are closing by the look of it. Okay, doors are closed, and I've arranged for those to be locked as well, so you're here for the duration. Good morning, everyone. Thank you for taking the time to attend this session, which is a big picture approach to architecture of System Center 2012. First thing to notice is that the name on the card differs from the person that's standing up here in front of you. Mark Priggett, one of our New Zealand consultants, was scheduled to deliver this session. Unfortunately, he has had some last-minute customer commitments that have come up and rendered him unable to attend. So he apologises for that. My name's Gareth James. I'm a consultant from across the puddle, as most of you can probably tell from my accent. And I'm covering off his session. Now, bit of a disclaimer here also for when you fill out your evaluations. I got the final deck for this at about 10 o'clock last night. So I haven't paced this, I haven't rehearsed it. And I'm happy for this session to be what you guys want it to be. If you want this to be more of a discussion, interactive, ask lots of questions, get into a conversation, that's absolutely fine. I'm happy for that to occur. I'm not going to be precious about trying to get through the whole deck because I didn't write it. So the session objectives and takeaways. Firstly, we really want to discuss what the architectural approach is for System Center. Now, System Center 2012 was a little bit of a departure from System Center 2007 where, and let's be honest, it was primarily a marketing decision to make System Center itself a product and that what traditionally were products in their own right, so operations manager, config manager, etc., are now considered as components of the entire System Center product. That's great from a marketing perspective and as it turns out for you guys, pretty good from a licensing perspective too. But from an engineering perspective, from a design and architectural perspective, let's face it, they really are still, in a lot of ways, beasts unto themselves. Some of them are quite large and complex products, particularly at scale. Anyone who's seen a config manager implementation looking after 100,000 or 200,000 seats knows how big and unwieldy sometimes something like config manager can get and the specialist skill set that it also takes to look after it properly. Because of the shift towards 2012 being looked at as a product, really what this session is about is when you're architecting System Center, looking at it to say, okay, well, I'm not going to look at it in terms of explicitly the individual pieces. I'm going to start by looking at it as a whole, and namely, there are a couple of challenges that present themselves when you're looking at implementation as a whole, and warning you about those in advance, as it says in the slide, some of the gotchas that are involved in that. I mean, these aren't horrendous things, but they are things that, if you know about them in advance, can certainly save you a lot of pain, and a lot of rework down the road. And then the other element to that is looking at the integration of those components. If you consider what integration you're going to use and how you're going to implement it from the start when you're in your architecture and your design phase, then again, that's going to do you very well when you start getting into your implementation phase. So that deck largely covers off what I just said in terms of numerous components, all part of the one System Center product. So and that's again a shift in the thinking that we now want to start applying to the architecture and design, and it's not just a marketing and a licensing thing. Seamless integration between various System Center components. I don't know if I'd call it seamless. Certainly 2012 there were a lot of advancements made and the product team did a lot of good work to try and make it, how do I put this? As easy as possible. I would say maybe as less difficult than it was in the past. I don't know if I'd go so far as to say that it's easy, but it certainly is far less difficult than it was when you're looking at doing it with the 2007 suite. There's certainly a lot more built-in functionality in the ways that these things talk out of the box, and certainly you have to do a lot less of that glueware in the middle, either using scripts or orchestrator or something like that. I mean, you still do that, and those things still do have their place, and some very powerful functionality can be leveraged when you do that, but the out-of-box connectors certainly do a lot more than what they have done. And why do we want to do this? Why do we want to take this big picture approach to System Center? Well, you really want to try and minimise your overhead. Now, a lot of what I'm going through gives the impression that we're thinking about a greenfields implementation, that you're architecting 2012 and you're putting the whole thing in holus bolus from scratch. I mean, realistically, for a lot of organisations, that's simply not an option. They'll have existing versions of System Center, in most cases not all of it, but certainly components of it, that they're looking in the first instance to upgrade from a previous version up to 2012. But this thinking of this holistic integral approach has to be applied to those types of projects as well. So if you're looking at upgrading what they've got existing from 2007 or previous versions to 2012, and then also potentially looking at introducing additional components, then you need to start to go in with that big picture. How are we going to make all these things talk, and how are we going to utilise that functionality? And that goes end to end. It's not just the implementation phase as well. As designers, as architects, we really have the obligation to look at the through life cycle and to look at the operation of these things as well. How are operational procedures potentially going to change or be affected by this further integration or putting in System Center as a whole? And the last point, again, is something that I feel quite passionately about, and that's not putting in technologies for technology's sake. Nothing makes me grimace more in a meeting when I ask the question why and I get the response because it's cool. What business need is that facilitating? And in most cases, don't underestimate the value of doing things more efficiently. I mean, a lot of what we do in System Center may not have an explicit business outcome in of itself, but it does potentially reduce the management overhead or reduce the resources needed to keep a particular service up and running. And time to do things and resources obviously always equate to money. So if you can reduce that, you're reducing your cost overhead, and that's a pretty valuable business outcome. So there's a lot there. I think the previous version of this deck actually had all the pictures flying in. So you can see there's quite a bit there to consider, and when you're looking at System Center as a whole, it is worth noting that you don't necessarily have to try and put everything in at the one time. What you want to do is you want your architecture to be overarching. You want that to consider how you're going to utilise these components. But if you think about trying to put it in big bang, then in a lot of cases you're going to end up with a project that's bigger than Ben-Hur, and you're within, you're negotiating with stakeholders, and you're in design for 18 months before you've even kicked a server build off. That's not necessarily what you want either. So a good way of approaching this, if anyone's familiar with the agile software development method, this is something that services is having an increasing amount of success applying to infrastructure projects. And I think looking at System Center as a whole, that can be an excellent example of it. For those that are not intimate or that familiar with Agile, one of the best components of it that's very well applied to infrastructure projects is this idea of iterative delivery cycles. So you architect the system as a whole, and then you decide, right, we're going to do this in phased implementations, or they call them sprints in Agile, to say, this is the functionality that we're going to deliver in sprint 1. We're going to bed that in, make sure it's reliable, and then potentially take changes from that, from once that's been running in. We may get requests back as to say, okay, this is working, but we needed to do this, this, and this now, and then you work that into phase 2. So doing that, applying that to System Center, you might say, okay, well, we need products X, Y, and Z now to deliver business outcomes. We see a roadmap of being able to leverage extra business value by putting in products X, Y, and Z in a later phase. So you architect for your whole vision at the beginning, you lay out the landscape of where you want it to go, and then you deliver it in phases. The other advantage to that is projects don't last forever. Things change, business priorities change, budgets can be taken away. So when you're planning those phases, make sure that phase one, don't ever assume that there's always going to be a phase two. And this is one of the advantages of Agile, is it says those phases, you want something complete that delivers a defined set of business outcomes in phase one. So if you get to the end of phase one and you've delivered 50% of your vision, let's say, then that 50% really needs to be delivering tangible business outcomes, because if something goes wrong or budgets get taken away or whatever happens, phase two doesn't get the go-ahead, then you can still hang your name on phase one and say we have delivered positive outcomes for the organisation. So just to quickly, for those of you who aren't familiar with what all of those things do, System Center App Controller is a web portal interface that primarily ties into System Center Virtual Machine Manager and also Windows Azure, or Azure, depending on how you're used to hearing it. That acts to be a single pane of glass between those two back-end technologies. Configuration Manager, I would hope everyone's pretty well familiar with. I don't know, I've never actually done active engagement work in New Zealand, so I don't know how popular configuration is and Config Manager is and how pervasive its install base is. I'm hoping that you guys use it a fair bit. It's obviously asset management, device management, operating system deployment, patch deployment, additional software deployment, those types of things. Some of these products are functionality starting to overlap, and I'll speak to that in a little bit. Data Protection Manager for backups, Endpoint Protection, which is now System Center Endpoint Protection, which is now just a checkbox in Config Manager. Whether or not you want to enable it, that's anti-malware protection. Operations Manager for monitoring. Orchestrator, which is definitely one of the more again, I don't know how it is in New Zealand, but certainly in Australia, Orchestrator is starting to get a lot of groundswell. I'm getting a lot of questions on Orchestrator, and a lot of people are very interested in how they utilise it. It's a very hot topic at the moment. In fact, I think my next session in this room, which is at 1:50, I think from memory, is all about Orchestrator Runbook authoring best practices. Service Manager, which I think a lot of people still, it's relatively new still, I think, and people haven't got their heads around what they can get out of Service Manager or how they might use it. But when you're considering a whole System Center architecture and the benefits for the integration of those System Center products together, those components together, Service Manager really is the central point of that. If you're going to do a whole System Center implementation without Service Manager, you're really not going to realise a lot of the benefits that are there. So Service Manager is designed to try and bring ITIL compliant process, is a technology medium of bringing ITIL compliant process to an organisation. So it's a service desk tool for tickets, it's a change record system, it's a CMDB. Now the idea of Service Manager is to be able to integrate inputs from all of the other System Center products that takes a lot of that arduous process away. How many, just quick show of hands, because I want to try and get some interactivity happening. For those of you who work in environments where ITIL compliance is in and you have a CMDB, how often do you see it that it just completely falls out of date because the process of going and updating the CMDB is just too arduous for admins to do on a regular basis, and you just can't trust the information that's in that CMDB. Anybody seen that? Yeah. So what we want to do is, through that integration from System Center into Service Manager, is we want those things happening automatically. When we provision a VM in Virtual Machine Manager, we want the configuration item for that VM to be automatically put into Service Manager. We don't want to have to do that manually. A CMDB is only ever as good as the latest information that's in it. If you can't trust that the information in that CMDB is the latest information, then it is utterly useless for its purpose. The other thing I'd say about Service Manager is, in a lot of organisations, again, I see from an implementation point of view, is everyone loves all of System Center, but as soon as you bring up Service Manager, the looks you get. It's like you've just run over someone's cat. And I think it's because a lot of organisations have tried to get their head around what Service Manager does and have sunk a lot of money quite often into alternatives for that, and quite often those alternatives are homegrown. It's not uncommon for me to see organisations that again will give you that look when you mention Service Manager. Why do they give you that look? Because they've sunk millions of dollars into a homegrown equivalent that doesn't work. And the the internal political fight to suggest that we need to use something else when you've got that sunken investment fallacy or false investment fallacy happening on the other thing can sometimes be a difficult conversation. So let's have a look at the integrated system architecture. Now I'm going to give you a little bit of a warning here. When I looked at the deck, I sort of went, 200? Really? Some of this content, I think, does dip well into the 300 territory, because we're talking really about some design principles as to how we do this now. So if this is a little deeper than people were expecting from a 200 session, I apologise. Again, if you want to make this interactive and start asking questions about business value and various other things, then I'm happy to have that conversation. So, busy slide number 1. This is to be memorised, and there will be a test as you walk out the door. This is really a guide. These slides are intended as a guide for you to use later on. We all know how this stuff works, right? I'll sit up here and talk for an hour, you walk out the door, and this is no reflection on individuals, it's just the way the human brain works. You walk out of the session and just go, yeah, I remember 4 things. So this is the way these things go. So what I want you to take out of this is to remember that there's some good reference information in this deck. The decks are available online after the event. Say, I remember that guy saying something about how we put this stuff together. Go back and revisit the deck. And this is not intended as, this is not a design guide, right? This is not a Bible. This is not that thou shalt follow. This is a starting point to give you an idea of what you're in for, to use as a base point when you then start to do your design research. So what we've got up on the screen here is how we would traditionally put all of the components of System Center in from a virtualization perspective if we're, say, going to house them on a 2-node cluster. This is actually taken from, I believe, our Fast Start guide for private cloud. So when you're talking private cloud, you're talking that you're putting in System Center, all of System Center, as a management engine for that private cloud that you're standing up. And in a lot of cases, the recommendation is that implementation is just to drive that private cloud and you don't use it for other things. So in that context, you would say reserve a 2-node virtualization cluster to house all of that infrastructure, and that's the way it's configured. So again, this is not the only way that it's done, but this is a recommended way within the context that I just stated. So you can see we have different levels of supplying high availability to each individual component. So obviously, if you're managing a private cloud or some kind of infrastructure with this, in a lot of ways it's a critical business function, especially if you're talking from a hosting perspective. If you're providing service to an internal business unit or even to an external provider, if you're charging for that service, if you're doing infrastructure as a service and you're charging for VMs that they consume per month, and there's a financial transaction happening and there's SLAs in place, this is mission critical infrastructure. If these components go down and you can't provision VMs, then there could potentially be financial penalties for that. So we want to make this infrastructure highly available. So you can see from the diagram there, we facilitate that via app controller, via network load balancing. Those next components on the layer up, so config manager, operations manager, service manager. A lot of the components, in fact, all of them we can look after with host level clustering. So that's simply protecting against hardware failure of virtualization host goes down, then VMs reboot on another host. Then we have native application HA. So a lot of these components of System Center have been in the enterprise for a while, and they're designed to be highly available, and they were designed to be highly available on physical infrastructure, in bygone years gone by, those of us who are old enough to remember putting, Update Express CDs into servers. So you have inbuilt application HA, so a more resilient service, more so than redundant. And then at the top level, guest clustering as well. Now, I get questions on this a bit is, if I'm virtualizing something like SQL, for example, and what do I do? Do I rely on the host level clustering to give me that failure resiliency, or do I cluster the VMs and run it in a more traditional SQL cluster as you would with physical boxes? My response to that is, I don't see why the two have to be mutually exclusive. It's not an and/or proposition. You can do both. Implementing SQL clustering within that virtualization clustering is a little bit more complex, and you do need to take into account that added complexity and what that might mean for you in terms of operational cost and also operational risk. That is important to consider, but then you need to weigh that up against the importance of that SQL infrastructure. If you simply rely on host clustering to deliver that outcome, then that will protect you from failures up to a certain level in the stack. So host failure, or what you would view as a hardware failure, typically, then you're protected against that from a host perspective. If something goes wrong within the guest operating system or within the SQL application itself, then your host management's not going to see that. And in many cases, even if you were to integrate it with Operations Manager, what can the virtualization layer do about it? In many cases, nothing. So if you've got a SQL box that, for whatever reason, not to say that this never happens on our operating systems, of course, but it blue screens, Operations Manager detects the blue screen, what are you going to do? Live migrate it? Great, you had a blue screen over there, get a blue screen over there, that's useful. So SQL clustering protects you from failures at the application and the application layer. So main things, there's a couple of things you have to be aware of, and that's you have to do a little bit of manual configuration in terms of node affinity. You don't want, because depending on the size of the cluster, of course, if it's a 2-node cluster, it's a bit difficult, but in a multi-node cluster, we have this idea of a fabric. VMs can be anywhere. It's just a pool of resources, and we don't care where in the fabric it is. Well, in the case of a virtualized cluster, you do care where about in the fabric it is, because you don't want both nodes of a cluster running on the same physical host if you can avoid it. So you need to do some manual config around node affinity and keep an eye on that. It's also a little bit more complicated in terms of management. One gotcha as well, depending on what version of Hyper-V you're talking about, whether it's 2008 R2 or 2012, you have different options for how you're going to facilitate that clustering. Obviously, a Windows cluster needs common disk at the back end, so you need to facilitate that common disk. In 2008 R2, the only way of doing that is supplying that through iSCSI. Hyper-V Server 2012, then we can do fibre channel pass-through as well. We're in this little bit of a limbo state where Server 2012's out. Announcement came through in the inbox this morning. Obviously, Hyper-V 3 is bringing a lot of those new features to bear. Sorry, I shouldn't call it Hyper-V 3, I get in trouble for that. Windows Server 2012 is bringing a lot of those new features to bear, but we're still in that flux state where Service Pack 1 for System Center 2012 is not out yet. So yes, sure, you can deploy Server 2012, but currently, until that release of Service Pack 1, we can't manage it. Scalability. So this can get a little bit sticky. I would actually, and this isn't in no way meaned as a put down, it's just simply a reality of the size of the market in which most of you will operate. I don't facilitate you seeing a lot of these problems in New Zealand, obviously simply because for most of your customers, the scale will simply not be there where you have to start worrying about these options. And to the same token, we very rarely see it in Australia as well. We simply don't have the scale. Our consultants who look after, massive organisations in the US do deal with these issues. So I remember I was in a config manager session at one of our conferences in the US once, and the presenter said, give me a show of hands of people who look after config manager environments with more than 350,000 seats. And about 6 hands went up. And I went, yeah, okay. The largest enterprise I deal with is like 110,000, and that's pushing it. So each of these System Center components have their own ways of scaling and also their own scale limits. So it's in most cases really about the number of seats that you're supporting. So obviously config manager, when you're talking about scale, you're talking about seats, and in many cases you're talking about number of desktop seats, because that's where the scale numbers really start to accelerate. So a component like VMM, we're talking about the number of hosts and the number of VMs we're managing. But be aware that there's very different use profiles for something like VMM. Quite often when I'm seeing whole system center implementations putting in, it's not just to manage server infrastructure. A lot of organizations are going, yeah, I want to go private cloud for infrastructure as a service, server hosting, but in the same time I've also got some kind of VDI deployment project running at the same time, and I want these environments to be able to handle both. A quick tip there is our best practices for VMM is to have a separate VMM infrastructure managing your VDI as what you do managing your server infrastructure, because they are such dramatically different styles of workloads. VDI places a very heavy load on the VMM server simply because it's doing a lot. There's a lot of machines being created, deleted, turned on, turned off. There's a lot of continuous activity happening that you don't tend to see with server workloads. Server workloads, you provision them, and then hopefully they're fairly static for a while. Again, looking at options in terms of scale up versus scale out. Some of our services scale up very effectively. Things like Config Manager and SQL Server will just, quite happily and very efficiently consume as many procs and RAM as you can chuck at it. Others, you sort of go, okay, it's actually more efficient to potentially scale out than it is to scale up. I mean, a good example of that is probably the orchestrator action server. If your action server is getting hammered, then in most cases it's actually more efficient to spill out into a secondary action server than it is to chuck more CPU and RAM at it. Data warehouse scale. This is obviously primarily for Service Manager and Operations Manager, where you're warehousing a lot of historical data, which then you maybe want to use SQL Server reporting services on to slice and dice that data to give you some business intelligence with which to make decisions. There are calculators, and there's some references there on that page that can help you do some indicative sizing of that data warehousing. Don't be scared of being conservative in those calculations. I mean, a lot of time it is cheaper in the long run to go a little bit bigger than you expect than to try and get your calculations, right on the line. I'm not going to pay for 1 megabyte more space than I need to. That sort of thinking. Just don't do that. But by the same token, it's all about balance. Don't go stupid the other way as well. I had a customer last week actually who sent me through a BOM for an environment that they were working on, and the SQL servers had 512 gig of memory. And I went, really? Do you think you need that? And the response was, it's better to need it and not have it. And I said, true, how much more are the servers? And as it turned out, it's that whole, cost scale thing where you get to a certain efficiency of price point and then the price point goes whack. So the servers with 512 were 3 times as expensive from a server perspective, not just the RAM. The overall server cost was 3 times as much as a server with 256, and 256 would have been more than adequate for their needs. I will throw in a throwaway comment there that the organisation that did the BOM and was doing the design for the server sizings was the same organisation that was selling them the servers. But that's it was like, nice try, guys. Do it again. Busy slide. Again, memorise, test. So just some recommendations around what we tend to see on average are good sizings for these individual components. Again, you'll notice that the top one there with the SQL Server, the recommendation is 8 vCPUs, rather difficult to do on 2008 R2 Hyper-V. Impossible, some might say. Again, obviously Server 2012 completely blows those scalability limits out of the water. I mean, 64 procs and a terabyte of RAM and a VM. it's hard to envision many workloads that would actually you turn around and say, no, this still has to be on physical infrastructure. In fact, when those Hyper-V scalability limits for 2012 were actually publicly released, Jeff Woolsey, who's our principal program manager on the Hyper-V team, just sent out an email to the field saying, we believe that these scalability limits will be enough that there shouldn't be any workloads that can't be virtualized. If you encounter a customer that says they can't virtualize because the 2012 VM doesn't give them the scalability that they need, I want their name, I want their phone number, I want what they're trying to do, because we want that information, because we've gone pretty high and we think it's enough. Some general tips there as well with the SQL Server and use of dynamic memory. Dynamic memory plays pretty well with all of the System Center products. There are some considerations for if you're using dynamic memory with SQL Server. There is an excellent white paper that goes into nauseating technical detail on how memory is used within SQL. So if you have concerns around using dynamic memory in SQL, that's a good white paper to go and hunt down. Reader's Digest version is that for the most part it's okay. One thing you need to be aware of is the amount of temporary cache or pooling cache, I think they call it, that SQL Server uses. It actually looks at your initial amount of RAM and says, right, I'm going to make the maximum size of my cache 16 times that value. So if you're giving dynamic memory to a SQL Server and you give it a minimum of 1 gig and maximum of 32, let's say, and you want to effectively use all of that 32 gig for your memory within SQL, when SQL sees that 1 gig initial startup, it's going to go, right, I set the maximum size of my my cache memory to 16 gig. And that's the most it will ever consume, so that the rest of that memory on that server is not being used as efficiently as it can. So just be aware of your startup values when you're using SQL Server. And there's a whole bunch of memory optimization settings that you can set within SQL to optimize it for dynamic memory as well, so which I can't remember because I'm not a SQL guy. Virtualization of System Center, again, sort of covers off what I was talking earlier about 2012. So whether or not you're deciding to do physical versus virtual, and yeah, there's a couple of camps of thought on this one. I mean, when you go to Microsoft and you talk to the System Center guys or the server guys or the infrastructure guys or virtualization guys, they'll go, yeah, fill your boots, virtualize everything, yeah, no problem. You go to the SQL guys and they're like, oh, we still like to do a couple of honking physical boxes and just, consolidate your instances and that kind of thing. So I'm not going to stand up here and say which way is the right way or a better way, more so to say that there are considerations that you have to go with. If you're working in an organization that has traditionally gone down, has very tight SQL efficiencies and very good density rates within servers. They're running a physical SQL farm and they've got multiple instances, and it's, they've got a team of DBAs and it's very well looked after, and they're providing very efficient service. I'd think seriously, I'm a virtualization guy, but I'd think twice about storming into that area and going, thou shalt virtualize. There are cases where it's not the best answer. I've talked about the Server 2012 Hyper-V host with increased support, so 64 vCPUs in a guest. There's also increased compute support for SQL Server 2012 as well. And again, not a SQL guy, but see if I can remember these figures off the top of my head. I believe 2008 R2 between standard and enterprise had virtual CPU allocation limits as to how much you could assign to those SKUs. 2012, those limits are increased and have now changed. So with SQL Server 2012 standard, I believe you're limited to either 16 cores or 4 sockets, whichever is less per instance. Enterprise is whatever the server's got. So Mac, if you've got whatever the limit is, 385 cores or whatever, fill your boots. Dedicated management forest. This is we're increasingly starting to see this as a good idea. Especially when you're starting to talk hosting scenarios, and supplying service to external organisations. you go into the design of these things and everyone's in agreement and everything's swimming along and, you're high-fiving each other after every meeting, and then you hit the AD design. And that's what gives everyone pause and go, ooh, yeah, actually, how are we going to do this? Are we going to have a dedicated management forest? Are the organisations that we're looking after, where are we provisioning those VMs? Are they in our domain? Are they in their domain? If we're managing their domain from our domain, then obviously there has to be a trust in place. For our forest from their forest, we have to have a trust in place. How difficult is that going to be? Will the organisation wear that? It needs to go through security accreditation, etc., etc. So there are definitely things there to consider, and where Active Directory was a pretty well understood paradigm and most people were comfortable with it, we're now starting to see a sudden burst. This talk of cloud and service providing and that kind of thing has really brought a burst of activity with a bunch of AD scenarios that people aren't quite as comfortable with, maybe because most people in an organisation are used to sort of single forest, single domain, or you're not used to dealing with more complex AD infrastructures. So again, we're not saying that thou shalt do this. We're just saying it's a really, really good thing to consider in terms of, do you have a dedicated management forest? One advantage, one scenario where we think that's a bit of an advantage is in managing multiple environments within an organisation. I mean, let's say you've got a really well-ordered organisation that has dev, test, pre-prod environments. Shocking, I know. I'm not seeing any cynical laughter, so obviously everywhere in New Zealand has dev, test, pre-prod and production environments, which is great. So traditionally the management of those areas, you'd have dedicated infrastructure, or either be it virtual or whatever, managing. You'd have a production one, you'd have a desk one, you'd have a test one, you'd have a pre-prod one, and that, or if they're managed at all, quite fine. You'll find the whole box and dice managing production, and then dev and test is just the Wild West, and there's no monitoring or anything in there. So one advantage of doing the multiple forest, or doing the management forest thing, and it could also potentially be a management domain as well, depending on the circumstances, is to have that one management forest then looking after each of those, dev, test, pre-prod, prod, each of those environments, and managing them as a single production entity. I mean, I know a lot of organisations that have this sort of contractual dichotomy between test and how they treat test, where they say test is test, and people can do whatever they want in test, and if test breaks, then our SLAs are no more, are heaps laxer than what they are in production. But in many cases, if you've got in-house developers, test is production for them. They do all their daily work in these development environments. If they go down, then you've got developers at X $1,000s a day sitting down twiddling their thumbs, not being productive. So in a lot of ways, these environments are they are production. They are production. So you need to manage them like production. The disadvantage to doing that is then you need to make a further investment into little dev, test, pre-prod environments for the system center infrastructure itself. So you can, if you're making changes or you're doing design things or whatever, you need to be able to test and verify those things and promote those things up through the levels as well. So you end up having a little bit more infrastructure than potentially you did before. But again, depends on the scale of the organisation, depends on the size, depending on how big their management and operational teams are, how, if they're siloed. There's a lot of things to consider when you're making those design decisions. SQL. Disclaimer, I'm not a SQL guy. I've spent as much of my, I thought when I first started looking at, tables and joins and, all that stuff that get DBAs really excited, I just looked at that and went, oh, really? So I've spent as much of my career trying to avoid as much as SQL Server as I possibly could. There's a couple of ways you can go. Firstly is just to have a SQL Server per System Center component. That's a fairly simple design. Obviously, if you're virtualizing, then having those multiple servers isn't going to have too big an impact on how much physical infrastructure that you need. Versus, do I have a clustered environment where I have multiple instances for each System Center product. Really, I think this comes down to how mature the organisation is in its SQL management. If they're not very mature, if they don't have a lot of experience in dealing with multi-instance servers, if they don't have a lot of experience dealing with clustering, then potentially the first route is a good way to go down. And again, this maybe is something that you can look at an iterative process for. An iterative is not only excellent from an implementation point of view, but when you're talking about an organisation's roadmap, you're really talking about two roadmaps. You're talking about their technology and their operations roadmap, and you're also talking about their organisational maturity roadmap. And quite often marrying those two things is a really effective thing to do, because you say, okay, well, right now you can say, let's go clustering and multi-instance and blah, blah, blah. You do not have the staff to support that. And if you try, you will most likely end up with an unstable environment that's not well managed, that goes down all the time. So understand you want to get there, and we'll help you do that. Let's start simple. Look at a road as to how we can employ people and get them skilled up, and build that capability from a maturity perspective that then allows you from an implementation and a design perspective to get more complicated. That make sense? Everyone still awake? I heard 3 people then, that's good. Okay, so some design tips and consideration. Again, dedicate an instance for each System Center component, so have an instance for each thing that you're putting in. Again, that sounds like a little bit of added complexity, and it is, but there's, as I get to I think in a slide or two, there's very good reasons for doing that. In fact, I'd actually say it's really mandatory. SQL Server Standard Edition can support a 2-node cluster, so don't forget that if you're trying to get maximum value from which SKUs you're selecting. If your SQL infrastructure is specifically to support System Center and your strategies there, then don't exclude the use of standard. The SQL guy is going to smack me in the back of the head as I walk out of the session for saying that. But if you want maximum value and you're looking at maximising that, then have a look at what standard can do for you, because in many cases standard will fill the bill for that type of infrastructure management. Sometimes it won't. So. I've gone through the SQL 2012 increase in compute limits for standard and enterprise, so that's something else to take into consideration. But what you also have to take into consideration when you're looking at something like SQL Server 2012, and in fact even next versions, and what your upgrade roadmap is and how you do your maintenance, when you build all of this as a single system and you're looking at the design of it from a single system, the people who are looking after the components really need to have that mindset that it is a complete system that is delivering a business outcome. Because there's what I call support lag. And we've touched on that with Server 2012. Yes, Server 2012 is out, but you can't effectively use it until SP1 for System Center comes out. So those are the support lags. Now, yeah, SQL Server 2012 is out. Does every System Center product currently support being installed on it? These are things you need to take in mind. So when you have one of these complete System Center environments with really tightly well-managed SQL at the back end, the SQL guys will want to put out the next version of SQL the minute it drops. You're going to go, whoa, hang on a minute there, guys. Because we need to make sure, let's look at our supportability matrix and make sure that everything that SQL cluster is running actually supports running on that version. And look, I'm going to confess and say that I think that we need to be doing a better job of that than what we do currently. I think sometimes those lag times are a bit too long and the support matrices end up being a bit too complicated. But there are, to be fair to the product teams, there are some substantial engineering challenges there that have to be overcome, and there's a reality to working in this type of environment. So it's a reality that you need to have in the front of your mind. Balanced component database load across cluster nodes. Yeah. I mean, obviously with SQL, when you're in a SQL cluster, it's not this argument over what you define as active-passive. You'll get some people who say, there's no such thing as an active-passive cluster. It's, or an active-active cluster because your instance can only run on one box at a time. And then you've got other people who say, well, you can call it an active-active because I can have instance 1 over here and instance 2 over here, and both boxes are doing something, so they're both active at the same time. So it's a waste of time semantic argument in my view. But the main thing to consider when you're looking at that is look at what your delivery of, the quality and what your SLAs are around delivery of service should one of those nodes go down. If you've got 2-node cluster and you're running them active-active, great. Are you exceeding 50% utilization on either of those servers? Because if you are, when one of them goes, or if one of them goes down, then the load that is running on that cluster is too much for one node alone. So you need to factor that. I mean, that might be, depending on your SLAs, running in a reduced state might be acceptable for a certain period of time. Or it may be unacceptable. If it's unacceptable, then you need to be very mindful on the loads that you place on your clusters and monitoring them to make sure that in the event of a failure, that you're not under-resourced. We have a design paradigm for that we call failure domains. I hate the term domain. I don't know why we picked it. I would have much preferred zone, because as soon as you say failure domain, people say, oh, it's a different Active Directory. No. It's really just the notion of saying how much loss can I sustain in the cluster and what level of service can I still guarantee. One of my other sessions, which is about architecting the private cloud, I go into a lot of these design paradigms and go into detail on them, so I won't cover it in detail here. Separate LUNs for data and logs for performance management and monitoring. Now, this is an interesting one as well, because quite often your SQL guys love disks. They love disks. They go, right, I want 45 disks on this SQL server, and I want, the mount point, and then I want all the disks under that mount point for every instance. So if you're running 20 instances, you end up with 125 drives, and they love it. And then you look at it from a storage perspective, and you sort of go, well, back in the days when a LUN meant a specific number of spindles, and you had to be very mindful of what your I/O output from that LUN was. Yeah, that was absolutely critical. And now a lot of storage vendors are going, we don't care. It's all tiered, and we dynamically move stuff around, and we've got layers of SSD and SAS and SATA, and it's all very sexy, and it moves it all around. And it's like I'm getting a bit much sales stuff here, and just dial it back a bit. But they go, we don't care. All the LUN sets can be on the same aggregate disk set, and the storage will work out where it needs to be. There still are some arguments for going with a more, old school design parameter of having those separated LUNs. And the real benefit of doing that, if there's no performance benefit, because the storage vendor do that tiered stuff and they just go, we guarantee service and we don't care what you do. The real benefit for still doing that is, again, there is a management argument to say it's very clear to the DBAs what's doing what. There's very clear separation. From a management perspective, you can say in some cases that if they're split like that, it's potentially easier to bring a LUN offline if you need to do expansion, or most of the time you can do that live these days, but people still don't trust that, so they still want to bring it offline just in case. If you want that it gives you that flexibility to say, yes, I can take this offline to do maintenance or expand or whatever I want to do on it, and the rest of the services can still keep going, and we're not taking out 20 instances because we've got them all on the one LUN. The other great reason for doing it is granular monitoring as well. So keep in mind that if you've got X number of services all on the one instance, all running off the one disk, if I want to try and get an indicative performance of what is this specific, if my disk's getting smashed, and I'm going, okay, well, one of these instances is driving this really hard, and they're all on the one LUN. It can be done, but it's a lot more difficult to try and work out what is the offending culprit in that environment. So if you've got them all on separate LUNs, then monitoring them separately and working out their relative I/O performance is a trivial activity. Scary slide number 3. Again, this is a guide of some architectures that we've done when we put in all of System Center. Now, this slide should be enough to convince you Because quite often infrastructure guys, when they put in SQL or put in System Center or put in those components, they tend not to give too much thought to SQL. They just go, yeah, it's a database, it's a necessary evil, I need it. I just get the server name and the instance name from the DBA guy down the corridor, and that's all I worry about. When you're designing and architecting System Center as a whole, the SQL infrastructure is complicated, and it is critically important to the performance and stability of that system. So if you're designing or you're architecting one of these all of System Center type of projects, if you don't have a good SQL guy on staff, then get one. and make sure that they're involved from the beginning with those conversations and with those designs, because the stability of that SQL environment can't be understated. Just about every time I see an issue with System Center, from either a performance or a stability point of view, it's always tracked back to SQL. So this is, again, an indicative, sort of an example design of how we potentially split those instances up, and then the LUN distribution for that. Again, this isn't, we're not saying thou shalt, but this is a good place to start. Who's ever seen that? That's a nasty little surprise when you're doing an install, I can tell you. Especially the first time I hit it. I went, what? Kyle, what? What the hell is that? Latin? Who the hell speaks Latin? So this is one of the reasons why you need to carefully consider your SQL infrastructure and architect System Center as a whole. And this is one of the gotchas that you need to consider from the start, is that the products have different requirements around SQL correlation, which is another reason why we say instance per component, System Center component that you're putting in. If you try and say, yeah, we got a SQL server, it's running onto that workstation under Fred's desk, we'll use that. Just, separate database for each product, no problem. So, as of the time, disclaimer, as of time of this deck being put together, those are the supported correlations for the System Center components. Now, again, don't use this as a thou shalt reference. This changes over time. So this is a good place to start, but when you're doing your architectures and your designs, make sure that you actually go hit the support pages and find out what the latest information on those supported correlations is, because it does change over time, and sometimes different correlations potentially will give you better performance. So it's something to go back and check when you're going through your design phase. Service accounts. Service accounts, groups and permissions. This is one of my favourite aspects of dealing with System Center as a whole. This is, again, don't underestimate this task. It is, especially when you're proof of concepting and you're doing stuff up in a lab, and it's really tempted to just go everything is admin and it just works. Not really acceptable for a production implementation. You really need to be following least privilege and making sure that that accounts don't have any more authority than they need to do their jobs. And that's complicated, right? There's no two ways about it. So you need to define all of the service accounts, groups and memberships permissions that you need in advance. Again, don't assume that installations will be done with enterprise or domain admins. In production, honestly, I want to see a world where we cut people's hands off for that, right? We might have some kind of a show trial first, but... And the other hobby horse that I'll jump on as well, because I'm an orchestrator guy, is the orchestrator. So orchestrator is an interesting paradigm in the enterprise from a security perspective. Because it's kind of a tool set that hasn't been largely used in the past, so it's something that security guys aren't used to seeing. And second, the best thing about Orchestrator is it has the ability to touch just about everything in the environment and do stuff. The bad thing about Orchestrator is he has the ability to touch just about everything in the enterprise and do stuff. From a usability perspective, from an automation perspective, and the benefits that Orchestrator brings you, it is brilliant. It's a security guy's nightmare, because the service accounts that you use within Orchestrator have access to, depending on what you're using Orchestrator for, pretty much everything in the environment. So that you have to be very mindful how you secure and how you treat those accounts. And it is not uncommon for Orchestrator service accounts to be treated in a different way from the rest of the service accounts in the environment, simply by virtue of the fact that they can, in many cases, access just about everything. That entails really doing a defence in-depth security assessment of what that means for the environment. You know, what threat vectors do you believe you face, and what mitigations do you have at each layer. You don't want to lose sight of what Orchestrator is there to do. I mean, if the security guys are coming in and saying, no, you simply can't have that access right, it's not going to happen, then you need to have a conversation, because if our Orchestrator can't do its job, then it's not much use. But you want to allow it to do its job, but you want to do it in a way that you are as sure as you can be that you're not compromising the security of the environment. And I've banged on about that enough. Use principle of least privilege. Scary slide number 4. Now, the good thing is that as I get towards the end of the slide, and I've got no idea how much time I've got. Ooh, I'm running out of time. I've been talking for too long. This is again an example of all the service accounts that you need, descriptions, and that kind of thing. Luckily, all of this we have covered in reference architectures, which are an excellent source to go and start to have a look at these things. Again, you may have to tweak around the edges for your organisation, but they are an excellent place to start, and they give you all of this information. Considerations for integration. I'm going to have to hurry this up. Plan for your integration from day one. Again, as I spoke about that agile delivery method, you need to be planning and have essentially your architecture for your end state, for where you want to get, for the business values that you want to get out of, and then potentially deliver in agile chunks. But you've got to have that view for what you're going to integrate and how you're going to do it from the start. And a lot of our architecture will say, you can do this, and you can do this, and you can do this, and you can bring this over here, and oh, look at that. In most cases, that only happens when you're using multiple System Center components in concert. The components won't do it on their own. And I spoke about this before, again, so I won't cover it in detail now because I'm running out of time. But again, that service manager being the central point for a lot of those integrations, and being a building block for a CMDB. But what's important is it's a building block for a CMDB that works, because you have the latest information in it, because the updates to that CMD are done by the system, not reliant on a human being to take time out of their day to do it, which we all know over the long term quite often doesn't happen. A nice diagram there with arrows. Useful resources. So the Microsoft Private Cloud Fast Track. Normally this type of stuff, when it comes out, I kind of look at it and go, eh. But I have to say, this is pretty good. I've read through most of it. I'm familiar with most of it because a lot of it's come from internal services offerings that we developed for the field, and it's been tweaked a bit and gone through marketing and legal and making sure we're not insulting anyone or whatever, and then gets passed on to you guys. But it really is from the field. I love this term, from the field for the field. MS Consultancy is out there implementing this stuff in real customer environments, and the benefit that we get in terms of places like Australia and New Zealand, where we simply don't have guys or girls who have the real world experience of large scale, simply because the environments don't exist for us to get that experience. Our US consultants do have a lot of that experience because they are dealing with these massive environments, and they're bringing all of that experience in to this guidance that we offer. So in many cases, when you look at this guidance, your thinking will be about, well, how do I scale this back? How does this make sense for a smaller environment? I find that when I'm applying these architectures to customers in Australia, that's more often than not what I'm thinking is this is great, but I'm not managing 50,000 hosts. I need to bring it back in a bit. So the Private Cloud Fast Track program is both a hardware program and also a reference architecture as well. So you can see some of the partners up on screen, and then that basically means that they have tested and validated their hardware against our reference architectures, and there aren't going to be any surprises. I was in a engagement about a month ago where they were trying to do effectively the fast track reference architecture, but they weren't using reference fast track hardware, and we were 5 weeks, I think, before we had a stable environment. Typical thing, trying to bed down what versions of drivers versus firmware versus storage firmware versus HBA firmware, that all have to be in line. Your NIC teaming software, firmware there, drivers there. All of these things have to be perfectly stars in alignment before you actually get a stable environment. The advantage of using this fast track hardware is that's all sorted out. You plug it in, you fire it up, you start deploying and it works. You don't have to spend weeks in this, 0.2 of a level down on my firmware, and that's why files were just spontaneously disappearing. Mentioned before the fast track reference architecture. So there's an architectural guide, a deployment guide, and that deployment guide is really, step by step, sort of screenshot by screenshot. It is either exquisitely detailed or nauseatingly detailed, depending on your viewpoint. And then there's also an operations guide. I mean, when we start thinking about the architecture of these things, again, as I said in the beginning, it's not just about the implementation. It's how do I sustainably operate this thing over time. And so you see it so often that architects and designers, think that they're being, really, really clever about something. In many cases they are. And then when you hand it over to operations, the operations just don't have the skill base in order to maintain an environment like that, and the house of cards completely falls down. And then you have to ask yourself at the end of that is, what business value have I actually delivered to the organisation by delivering something that's so complicated that we can't actually run it? So that operational running and providing that business value over time, over the operation of a system, over the life cycle of a system is critically important to actually delivering real business outcomes and real business value. There's some labs, I guess. Again, these decks will be available, on the website post delivery, so they are something you can go back and reference. That how to architect the private cloud, that session is mine, and I think that's at 4:30 in New Zealand too. There's some related certification exams. I should probably do those. Yes, I'm here today, but I'm flying back to Australia tomorrow. So I may be hanging around the hub at various points during the day when I'm on the 15th cup of coffee. But if you have any questions or want to have a conversation about something, my email address is up there, gareth.james@microsoft.com. So feel free to drop me a line if you have questions. Track resources, that wasn't updated. Fill out your evaluations and win stuff. Thanks very much for attending.